Welcome to this training module on Ranch Development, Chapter 4 of the Hill Country Axis Operating System Master Reference. This chapter establishes the applied infrastructure standard governing the physical build-out of the ranch, including pen specifications, utility infrastructure, fencing, the camera network, the grow-out ranch, and the phased construction plan. The governing principle of this chapter is straightforward. Infrastructure exists to serve the deer, the data, and the family in that order. Every structure on the ranch should reduce stress, improve observation, or preserve knowledge. If a structure accomplishes none of these three objectives, it does not belong on the master plan. Let us begin with the property and site overview. Hill Country Axis operates across two adjoining ranches in Menard and McCulloch County, Texas. Rain Creek Ranch comprises approximately 3,200 acres and holds the breeding complex, handling barn, and administrative core. El Chital Ranch, the neighboring parcel of approximately 507 acres, hosts part of the grow-out ranch, known as Buck Academy, along with the family residence. The combined property was selected for its rolling terrain, suitable for a graded feed lane, dependable groundwater, and native hill country cover, including live oak, juniper, and native grasses. This vegetation supports both animal welfare and the visual character documented in the ranch's ongoing film series. It is essential to understand the two-ranch partnership structure. Rain Creek Ranch owns the breeding pen complex and provides the facilities. El Chital Ranch provides the day-to-day labor. Net proceeds from the breeding program are split between the two ranches under this arrangement. Section 4.2 addresses the master ranch concept and functional areas. The project is organized around specialized functional areas rather than a single large herd. These areas include the foundation pasture, the breeding complex of 25 pens, the central feed lane, the handling barn, the grow-out pasture, the family residence, and the camera network infrastructure. This separation of functions reduces stress, improves management, and allows for better genetic selection. The master planning principles guiding every design decision are these: design around deer movement before vehicle movement, minimize unnecessary handling, separate production functions, reduce labor through thoughtful infrastructure, and ensure every expansion fits the original master plan. The foundation pasture serves as the lowest stress environment for the breeding herd. Approximately 20 acres in size, it begins with roughly 20 does and 2 to 3 breeder bucks. Feed, water, and mineral stations are serviced on a fixed, low-frequency schedule with minimal human disturbance. Observation occurs through cellular-connected game cameras and a thermal drone program used to locate new fawns for bottle feeding. Selected first-generation fawns are bottle-raised into the managed breeding program, allowing wild herd behavior to continue undisturbed while establishing calm, manageable genetics for the future. Now let us examine the breeding complex and pen specifications in detail. The breeding complex is designed around 25 managed pens connected by a central feed lane. Each pen houses one defined doe group with one assigned breeder buck during breeding season. Pen fencing consists of welded wire or pipe game fence, a minimum of 8 feet in height. Every pen backs directly onto the central feed lane for single-pass servicing, using triangle shapes for efficient animal movement. Standard equipment per pen includes a gravity feeder, an automatic waterer, a hay rack, and a mineral feeder, all serviceable from the lane side. The pens follow a fan pattern radiating from junction stations along the feed lane, narrowing to a point at the western apex, designated Pen 0, and widening near the handling barn. 9 stations run west to east, each with a north and south pen, for a total of 19 named locations, plus the apex. This numbering system is fixed, though exact pen boundaries await Phase 1 survey confirmation. Pen rotation and management deserve careful attention, as continuous occupation of the same ground concentrates manure and reinfects it with parasite larvae. Rotation is driven by 3 trigger types working in combination: a baseline calendar rotation of approximately every 90 days, fecal egg count thresholds that trigger early rotation, and life stage events such as weaning or pre-rut buck introduction. Rest period standards vary by season. Peak summer heat requires a minimum of 60 days of rest, while fall through spring requires 90 to 120 days, owing to slower larvae die-off in cooler, wetter conditions. The sanitation protocol between rotations includes manure removal, ground treatment with agricultural lime, disinfection of hard surfaces, and a minimum 48-hour closure period before a pen returns to the rotation. A companion chemical and biological management layer addresses parasite resistance. Rather than blanket treatment on a fixed calendar, the ranch employs targeted selective treatment, treating only animals showing clinical signs of heavy parasite burden. This preserves a population of drug-susceptible parasites, slowing the development of anthelmintic resistance. Biological controls under research include nematode trapping fungus and condensed tannin forage, both of which have shown substantial reductions in fecal egg counts in related livestock trials. The central feed lane is the infrastructure backbone of the entire ranch. This single graded corridor allows one person to service all 25 pens in a single daily pass without entering any pen, eliminating routine handling stress and keeping feed dry and free of contamination. The lane is designed to scale to 200 breeding does without adding staff for routine feeding. Morning feeding occurs between 7 and 8 a.m. daily, doubling as the primary daily observation window. The handling barn functions as the operational hub of the ranch. Every movement of a deer should be intentional, and this facility is designed to minimize handling time, reduce stress, improve safety, and collect accurate records. It includes a working facility with a squeezed chute sized for axis deer, an integrated livestock scale, a veterinary area for health checks and DNA sampling, a feed room maintaining a minimum 30-day supply, and a record collection point wired directly into the ranch operations database. Water, power, and utility infrastructure form a critical system rather than a mere convenience. Every pen is equipped with an automatic waterer on a buried, freeze-protected supply line. An emergency backup system provides 500 gallons of water accessible by ATV within 2 hours of any system failure. A dedicated Wi-Fi network built across the breeding pen complex carries the primary camera feed, while cellular-connected cameras cover the foundation pasture and the El Chital grow-out area, also serving as backup coverage should the Wi-Fi network fail. Regarding medicated water delivery, the design principle is unambiguous. Water delivers hydration to every pen, and when a veterinarian directs it, targeted treatment to one pen at a time. It never delivers routine mineral supplementation, and it never doses the entire complex simultaneously. Minerals remain in dedicated free-choice feeders so that each animal self-regulates its own intake, which is essential for narrow-margin minerals such as copper. Fencing and perimeter security protect both the genetic investment inside the fence and the land beyond it. The standard perimeter is a minimum 8-foot game fence, corner-braced, running continuously around the foundation pasture, breeding complex, and grow-out ranch boundary. Interior pen fencing uses welded wire or pipe panel construction, while the quarantine group maintains a fully isolated fence line with no shared boundary. An important refinement involves windscreens and visual barriers. Because deer are prey animals, an open sightline through a fence can trigger pacing, fence testing, or panic. Solid, densely woven screening is placed strategically at pen corners, lane junction stations, the shared fence between mature buck pens, the quarantine perimeter, and the handling chute approach. This reduces visual stress at the specific points where it matters most, without the cost of screening the entire perimeter. The camera network infrastructure is a permanent component of ranch infrastructure, providing the primary visual data stream for the Hill Country Axis Intelligence System. Fixed cameras cover every mineral and water station, supporting daily consumption monitoring, while pen-level coverage supports observation of body condition, injury, and behavior. Daily photographs of every identifiable animal are captured and processed through an AI recognition and growth scoring system. This system confirms identity against ear tag and coat or antler pattern and produces a body condition score for that animal on that date. Identification proceeds through a layered process: pen assignment as a first filter, visual matching against existing photo history, and ear tag cross-check where visible. Any image that cannot be matched with high confidence is queued for human review rather than automatically assigned, since an unreviewed misidentification could silently corrupt an animal's growth record. The Grow Out Ranch, referred to within the ranch's documentary series as Buck Academy, occupies the neighboring El Chital Ranch. Here, promising young bucks develop under lower stocking density while breeder evaluation continues, separating genetic evaluation from the breeding herd. This near-natural environment supports full antler and body expression evaluation before a buck is confirmed as a breeder, sold, or retained. Roads, access, and vehicle flow follow the same low-disturbance principle governing deer movement. All-weather calash or gravel roads connect the entry gate, headquarters, handling barn, and feed lane. A single primary access road serves the property, with interior branch roads serving the Grow Out Ranch and family residents separately from production traffic. Feed and equipment vehicles use the central feed lane corridor rather than crossing pens directly. Construction and development phasing follows the order in which the herd actually needs each system. Site preparation addresses road grading, well and water infrastructure, and power drops. Perimeter and foundation pasture work follows, including high fence installation and feed and water stations. The breeding complex phase constructs the central feed lane, followed by the 25-pen build-out. The handling barn, camera network, and Grow Out Ranch phases complete the sequence, culminating in the family residence being sited concurrently with Grow Out development. Finally, infrastructure performance is tracked through the Ranch Development KPI dashboard, ensuring facility issues are identified before they become welfare or data quality problems. Water or functional uptime is checked daily, with any dry water triggering same-day manual delivery. Feed lane service time is measured daily, requiring all 25 pens to be serviced within a single morning pass. Fence line integrity is inspected weekly, with any breach triggering immediate repair. Camera coverage uptime is reviewed weekly, targeting 95% of stations reporting. Feed inventory must maintain more than 30 days on hand, with any drop below 20 days triggering immediate reorder. Pen rotation compliance is logged at every rotation, ensuring 100% of pens meet the minimum rest period before reoccupation. This concludes the training module on ranch development. Every structure, every system, and every protocol described in this chapter exists to serve the same governing purpose: reducing stress on the herd, improving the quality of observation, and preserving the knowledge that will guide Hill Country Axis for generations to come.